Welcome back. I had a couple questions that were asked through my classes, and I want to make sure I can give an option to show off how to answer them. So we have a couple questions here, and so welcome to Database Questions Video Edition. One of the ones that we have, especially we see with students early on, is why is my query breaking when I have these little curvy quotes, the curvy double quotes, and what they're called smart quotes. And the fancy quotes that you see when you're working with your regular text editor, like say, I'm right here inside Google Docs, or if you're inside Word, when you normally go type a quote right there, it's going to give the nice little curl for that. And it looks really great for the idea of using a font style approach. However, our compilers and our editors, the tools we use to actually write code, and the parsers that work behind the scenes inside them, they don't like these fancy quotes because, well, when they're designed to actually parse the text that we're working with, all they truly understand are the specific values they're looking for. They're really, again, they're dumb machines. And so we can't use fancy little things like that. So you want to make sure you're using the regular boring quotes or boring single quotes like this. You can tell they're usually pretty vertical. They're not very fancy looking. They've got a nice little big font on this, so it's really quite obvious. But they're just really boring on that. And so if you're using your a proper text editor, like Notepad on a Windows box, TextEdit on a Mac box, or any of your IDEs, those are it's the fonts that are automatically designed to work for this. They're not really pretty necessarily, but they're really good for showing the information we need to work with. And so that's a quick way to identify you've got the right thing for it. If I simply just go up here and I go to File and I go to Save As, or Download As, and I choose a plain text file, that's still not going to necessarily give me the correct information. So you want to make sure you just work with the correct tool by default. So when you're creating your files, use either your editor you're working with to do your IDE that you're working with to actually write the code and put those in, or make sure you're using a simple editor like I said earlier, TextEdit using plain text format, or Notepad by default in Windows boxes, or any of the basic text editing tools on a Linux box, and use that to actually create that right there. The next one I had especially was, what is exactly a Cartesian product? What does it look like? Where is it used or found? And so a Cartesian product is what happens when I'm creating a Cartesian product is what happens when I join tables incorrectly. And so I have a really bad example right here. So table1.filled and other table.filled from table one and other table. And so I'm just separated by commas. And what happens is when you get a Cartesian product, you're going to take all of table one and all of table two and multiply your results down like this so that every single possible value for every single thing on that. And it's just, yucky. It doesn't really do that. If you're looking at matrix multiplication, you might remember that from your math class, and how ridiculously huge, how tall those values get when you're multiplying a matrix. That's what's happening right there, because we're specifying those two columns, but every possible value between them is going to match up. So it's basically multiplying the number of results. So if there's 300 rows in this one and 400 rows in that, we're going to get 12,000 rows out of that. Not so nice. So you want to make sure that when you multiply those results, you don't do it appropriately. And that's why the join on clause is my favorite way to do this, because when you do the proper join on that using that primary key, foreign key relationship, you get the results exactly what you're looking for with that. And then you can, of course, shrink those down by using your proper use of your where and having clauses. So cool stuff with that too, but we'll take a look at that another time. The next question is, what is the order of each clause performed and when my code is run? How do I use that information to write my code? And so the execution order is like this. So it goes first the from/join clauses. So those are the clauses that specify the tables we're working with. So I'm going to grab those tables and I'm going to put them together with the on. And that's going to combine my tables in the appropriate structure using the from/join/on structure. Then I have my where clause, which is going to squish down my results for the rows that only I want to work with. Then I have my group by, which is why I coalesce results into chunks that I can use to do cool stuff. Then I have having, which is how I can filter results further based on those lovely aggregate function results. Then after using all those, then I pick the columns I want using my select clause. That's where I pick the things I'm going to look for in the vertical columns. And then finally, if I actually have to, I sort my data. That's up to me though. How do you identify the foreign key in a query? It's just whatever value you're importing. And so this is where we want to look at our ER diagram, our schema, or if we're looking at the DDL language, we'll take a look at that in another video as well. But as you can see right here, I have that lovely FK right here specified on my grade type weight. My grade type code is the foreign key I'm working with. And that's how I can identify. I'll look for that FK identification on there. And that's where I'm going to make that join right here. So that grade type code is going to join onto that grade type weight on that grade type code PK FK relationship. And that's how we can identify, is we look for the things that shared in common based on both name and type. Now they don't have to be the same name in both tables. We'll see that some other examples as well, but that's how I look for it, is look for that relationship, and that's a great way to identify it right there. Why shouldn't we use the two-char results on a month or month mask? And so this is what one of the questions that a lot of students had where they're trying to have some problems when they're trying to solve some of the questions in SQL searches that require date comparisons. And the problem is when I use the month or month spelled out right there, I know I said it really weird, but we're going to get the result of the word of the month but some padding on that. And the amount of padding actually depends on what language you're working with, or if it's a set amount of padding, how, like, so 9 characters wide. And it's like, that doesn't really help. And so when I'm trying to do like that, when I try and write my solution, I'm looking at June right here, but it actually gives me June with some spaces after that. And as we know from our regular programming classes, June and June plus spaces, they aren't the same. It's like, it may look the same, especially if we're not looking, because you don't see the actual quotes that are around that, but the computer knows it. It may be a stupid, slow, fast machine, but it knows the difference between spaces and nothing. And so that's where we have to keep that in mind. So when we're using that, we want to instead use the idea of using the MM for that. And so the MM is the digit-based comparison that we can, like, oh, I can always compare the 02 or 06, or always 02 or 06, because they're numeric values and they're easy to compare. Another one we have is, what is the point of this dual table? Why is it made? What's an example using the dual table? And so in Oracle databases, the dual table is how I do simple calculations. Other database engines allow you just do a select and some result, but or some query that we're looking for some data. But if we want to actually do a select clause in Oracle land, I have to give a from on a table. And so the dual table is the dummy table, just like, hey, I don't actually have data in here, but I want to be able to get information. In this case, I want to get the today using the DDMMYYY, or the month DDSP, so I can get the spelled out version of the day on that as well. And I also can do some numeric information where there are 3 plus 3 for addition, getting me 6, or mod 4, 3, I get 1 because it's the remainder on that division instruction. And so that's how I can get information with that. We had a couple questions about aggregate functions as well. How does count specific columns if it's counting everything? And so what this comes down to is the way that count itself works. If count is by itself, it just gives us the number of tables we have inside that column. If count is by itself, it just gives the number of rows that are inside that table. Not really that helpful. However, when count is combined with other bits of information inside that select clause, we group those results, and so the count then gets the matching count for each of those subgroups inside that. And that's where order by gets really powerful and fantastic. And so I can put those results together. I have a video that's on my channel. You can take a look for some more detail on that as well. Can you manually calculate the results given by an aggregate function? Well, yes, you can. What you would need to do is you need to make sure you run that query over and over and over and over and over and over and over, getting all the values you need. Of course, knowing exactly how many numbers are inside in the first place, but yeah, we don't want to do it. Then you have to do the manual math of, well, this plus this plus this plus this plus this plus this plus this divided by that to get the average, of course. Oh, yeah, no, we don't want to do that. Aggregate functions are there because they're powerful tools we want to use. They save us time and work, and we want to use them appropriately. And a couple subquery questions we've received. What is the difference between the keywords in and any for comparisons? And so the in comparison is one an exact match of any specified value. And that specified value can be in a paren separated list with commas, or it can be the result of a subquery. And so it's looking for an exact match, aka an equals comparison in Java is what we'll be looking at for this. Or an equals, of course, since we're in database land. However, the any comparison is like, oh, it's less than any of them, or it's greater than any of them, or it's greater or equal to any of those values. And so it has all those multi-row values of a subquery, but it's a relational operation against all of them or any of them. And so that's where the any or all come in on that, so you can use those different operators. Where do you put non-scalar subqueries? Well, they can work great in a from clause because that's an inline view, and you usually want to have multiple rows to actually look on that. A join, same thing, again, an inline view. And an aware clause, especially what we were just talking about with the idea of an in or an any based clause, you want to look inside a bunch of values. That's another place that we really want to use a non-scalar query, aka multi-row query. Can I put an aggregate function around a subquery? And the example is given like count select from. Of course, we don't want to put anything inside the parens of our count. All we get is the asterisk that we've talked about before. But as you can see right here, I'm getting that same result that was specified in the student's question. So I have select count asterisk as numbers from select parens, and then select sum filled from some table, parens inside query. So I'm going to grab that subquery of sum filled from some table, grab that as a query, and then I'm going to get the count of that on there, and that's how I'm going to get that information from that. And so I can put a subquery together with that and go from there. And so those are some couple of demos of things we can look at and how you can answer questions. Hope this is helpful for you. We'll have a great time. We'll see you next time. Have a great day working with databases and solving problems. Cheers. See ya. Bye-bye.